Hello everyone, welcome to Instrumentation Academy. In this video, we will discuss how medical oxygen is produced in hospitals at low cost. The air that surrounds us contains 21% oxygen, 78% nitrogen, 0.9% argon and 0.1% trace gases. This air enters the air compression block through a dust filter which filters the dust particles in the air. The air compressor has a spinning rotor which is away from the center. Arms with self-adjusting length create cavities of varying size. The incoming air fills the cavity and travels around. As the cavity gets smaller, air pressure goes up. Compressing the air makes the molecules move more rapidly, which increases the temperature of the air. The compressed air is now forced out through the pipe. Moisture in the compressed air used in oxygen plant can cause problems in the operation of the plant and can adversely affect the process. In order to avoid this problem and to supply dry air, an air refrigerant dryer is used. This refrigerant dryer eliminates any water vapor remaining in the compressed air. The warm moist compressed air enters the dryer which cools it rapidly, and the water vapor in the air condenses into pure water which is collected in a water trap. The dry air in the chamber is reheated to room temperature and fed through an outlet. Now the air is allowed to pass through oil coalescing filter which efficiently removes oil aerosol, wet dust which would come from the lubrication of compressor element, the intake air and the compressor installation itself. The output air coming from the filter are fed to air receiver. This air receiver acts as accumulator and the air supplied to this air receiver must be dry. Compressed air from the air receiver is now fed to oxygen generator. This oxygen generator works on the principle of pressure swing adsorption. This pressure swing adsorption technology utilizes the ability of a synthetic material called zeolite molecular sieve to absorb mainly nitrogen molecules from the air at high pressure and release this retained nitrogen molecules once the pressure within the generator is decreased. The pressure swing adsorption generator has two separate adsorption tanks which contains zeolite molecular sieve as adsorber. Dry compressed air from the air receiver is blown through a valve V1 to the first tank where the pressure is built to reach the operating pressure. As the air passes through the zeolite in the first adsorption tank, the nitrogen molecules get trapped in the pores of the zeolite while oxygen will pass through the adsorber and exit as product gas. This takes place until the adsorber has reached its maximum adsorption capacity. Simultaneously, the second tank is depressurized to atmospheric pressure by opening valve V4. When the atmospheric pressure is reached, this valve V4 is closed. Just before the zeolite in the first tank becomes saturated with nitrogen, the process switches oxygen generation to the other adsorption tank, that is the second tank. So the inlet compressed air is diverted to the second adsorption tank through valve V2. At the same time, valve V1 gets closed. The inlet compressed air will take so much time to pressurize the second tank. To avoid this time delay, pressure equalization valve, that is valve V6 is opened so that the pressure in the first tank and the second tank equalizes. Now the second tank reaches the operating pressure and starts producing oxygen. A small portion of the generated oxygen of the second tank flows from top to bottom of the first tank, which is required to push out the nitrogen that was trapped in the zeolite. Now as the pressure inside the first tank reduces, the zeolite loses its ability to absorb nitrogen and starts releasing the remaining nitrogen that was absorbed earlier. This released nitrogen is vented out from the system through valve V3 and the zeolite becomes regenerated. By doing that, the system makes room for new nitrogen molecules to attach to the zeolite in the next adsorption phase. These operations are alternatively repeated in both the tanks and the pressure is continually swinging between a high pressure at adsorption and a low pressure at regeneration, and hence the name pressure swing adsorption generator. The oxygen produced by the generator is stored in a buffer tank. From the buffer tank, oxygen is taken to the user end through a bacterial filter. An oxygen analyzer is used to check the purity of this produced oxygen. oxygen booster is used to increase the pressure of the oxygen to meet various requirements of terminal user, and this oxygen booster is connected to cylinder refilling station where oxygen cylinders are refilled. Advantages of PSA oxygen generator over cryogenic oxygen plant. Investment cost of PSA generator is less than half of that of an equivalent cryogenic oxygen plant. PSA oxygen generator's startup time is only 5 minutes. Therefore, depending on the oxygen demand, generator can be switched on and off very conveniently. While cryogenic oxygen plant startup time is around 12 to 16 hours. So, cryogenic oxygen plant cannot be switched on and off very frequently. PSA oxygen generator is very compact size unit and does not need a dedicated manpower. It keeps working round the clock without any supervision. While a cryogenic oxygen plant is very large equipment requiring lot of sophisticated controls and the maintenance cost is also high. So dedicated manpower is needed to monitor the operation of cryogenic oxygen plant. PSA oxygen gas can be stored in a standard economical tank, whereas cryogenic oxygen is to be stored in a vacuum insulated double-walled tank. Cost of this storage tank is therefore high. Considering all these advantages, we can say that PSA oxygen generators are best suited for medical oxygen generation in hospitals. By this we come to the end of this video. If you like our video, please click the like button below and make sure to click the subscribe button and the bell icon also so that you can get notifications of our further videos. Thank you. Have a nice day.